Welcome back, I guess. I still want to... Okay. Let's continue. Can't wait for everyone to get back, but probably people will drip in. VCC this is on the bottom. Oh, I'm actually doing it wrong. Because from the top on, it's PO2, VSS, VCC, and ground. And P13. And I wanted this to be the ground line, so that has to go on the other side of the capacitors. Well, no biggie. Okay. Yeah, I guess the positive bit of all this shenaniganery is that I'm pretty sure that the glue is all dry now, so my chip won't go anywhere. Okay, VSS. Let me just double check. This is 1, 2. Crap! Did I make a mistake? It's like this. Sorry, your view is... No, your view is the same as mine. It's just that YouTube on their screen assumes a webcam, so it flips it. Why does this blink so much? Don't blink, you piece of... Okay. A1, so this is correct. This is... Oh no, did I already make a mistake? No, I did not, because this is A4 and this is VSS, so the second down. So just as an indication, the second down on this row is the ground. So you need to connect it to that. Should I put some flux on there? I probably should put some flux on there. Don't worry, you're not watching Louis Rossmann. I'm not going to drown that little chip in flux. That's the drop. Something like this. Yeah, all the people who are back now, sorry, my microscope my microscope camera does not like having both HDMI as well as USB. And the irritating bit is that if you're connected to USB, you can't see the menu, so you can't modify like the auto exposure, etc. That seems to only work in HDMI mode. But as far as I can see, I can't have USB as well as HDMI connected at the same time. So if I'm streaming like this, my only way to easily get that is to effectively take the HDMI, then feed that into some USB capture card, and then feed that into YouTube, just so I can see the menus. It's a bit, yeah. I mean, otherwise, I don't mind this thing. It's pretty okay, but that's a bit of a quirk. Focus. Okay, no more procrastination. Did you see that? That chip moved. That's not good. No, it can't have moved. It's stuck. It might just have been a... No, it did move. I guess the glue, when it heats up, doesn't glue anymore? That's curious. Yeah, gotcha. That is a joint. Let me zoom in. Okay. Oh, that looks absolutely great, aside from the fact that I now wicked all the solder of the neighboring balls. Nope. Okay, first one made. Yay. Now for VCC. Zoom out. Sorry for the wobbly cam. Mm-hmm. Oh man. Honestly, I don't have very... I usually have pretty precise motor control, but this is so tiny. Okay. This is gonna be the second wire. Oh yeah, if it doesn't run away from me. Oh, come on, don't do this to me. And that is a fix. Mm-hmm. Okay. Now the capacitor connection for the internal LDO is the one that is a bit to the middle. So now I'm going to run the risk of desoldering the other one. See what happens. You are nice and connected. Okay, wait. Now there's not that many to go. Like I need the 3 pins for the power. I need a reset pin. I need 2 pins for SWD, and then I can see if I have a live chip. And obviously, for all the LEDs I want to connect to it, I need to solder a wire to it as well. And I'm not sure if I want to, but we can try. But at least to prove that this is working, I only need a few. Mm-hmm. That is a bit more than I hoped for. Where are my wire cutters? This has about as much production value as it has preparations. I have just about like 50 wire cutters all over the place, and obviously the only one that is here is the one that has the big sharp cuts out of it, because I try to cut stainless steel with it, which is not really usable if you want to cut this. Let's see. Where are my tools? Tools. I'm just taking a new one. Oh, geez, that's not visible at all. Zoom out. I'm taking a new one. These are still protected for my safety. Oh yeah. Look. That is probably like, I don't know, 10 seconds away from getting its first cut, knowing those things. Oh yeah, the tip breaking off. Yeah, that's also something that's happened. And then I'm not talking about the ones that are misaligned right of the factory, which is also fun. Okay, zoom in. Oh, this is nice. The field of view is right. So I thinned a bit too much. Yeah. No, it's okay. Let's see. This thingy needs to go to that. Ah, jeez. Okay, I'm gonna rotate it. That needs to go there, which I can reach now. Oh, that's way too much solder. That is still too much solder. Oh, my Matcal turns off automatically because I tend to be stupid and forget to turn it off, and that is a lifesaver, but it sometimes does it too often. It seemingly uses the amount of energy it needs to put in the hand thing as a reference to if it should turn off or not. And obviously, if I'm soldering these things, these have no thermal mass at all, so it does not detect it. Okay. Right, that is soldered. Let's see if it still looks good from the side. That is super close. Yeah, I really ought to buy like in a good cutter. Jeez. And obviously, like seconds after I grabbed a new one, I find my good one here. This always happens. So what am I gonna do about you? Because you are really, really, really close. I don't dare to mess with it because I'm afraid I'll break off the pad. I'm decently sure the stuff between there is only flux, but okay, let's just go ahead and redo that because I am not comfortable with that joint, and I'm not sure how happy that chip is going to be if it sees 5 volt or 3.3 volt or whatever on its internal LDO rail. And after I've soldered this chip, I probably really don't want to That's already moving. Oh my. Pad seems still attached. I hope that it still works. This is one of those balls that if I manage to break it off, then the entire chip won't work anymore, because this is, well, no, it might work actually. It's only connected to a cap, but it is for the internal LDO of the chip. In other words, it's if I mess it up, the internal LDO will probably get really unstable. I might get a blink, but I'm not sure if I... well, technically, I was about to say, I'm not sure if I want to use it in production, but look at what I'm doing. I'll probably not use this in production anyway. Okay, attempt number 2. Come on. This is actually easier than I thought, honestly. It takes a lot of time for sure, but let's see if I can see. That is... oh yeah, that is way more the way I'd like it to be. Okay, so for those middle paths, I just probably have to go in like in all the way from the top. That's good to know. And that's also one of the reasons I'm doing this, is like, aside from, you know, bragging rights, I just want to know if I'm capable of doing this in the first place. So. Okay, what's next? We need to solder the SWT things, and those are... I already forgot. SWD. I think it's 27 and 28. I'm not sure. 27 and 31. And those are balls, 27 and 31. Okay, D3 and D4. So these are the balls right under the 2 I soldered most recently. That is good. Let's move those here. Maybe I should solder those to 2 pads so I can solder an extra wire to it without having to worry that I'm gonna mess up the joint to the ball. Let's do that. Yeah. A little bit of wire. You too. Cut that off. Why did I put that wire under the others? That is not the way I want it to be, but it is the way it is going to be. Ah, crap. Oh, you gotta be really careful. I really don't want to break off any of those wires. That is good. That also insta-coated those balls in flux. Oh. I'm gonna clean up a little bit around this workplace because this is like a desk that is super messy, but if I can't put my wrists down, that is not good for the amount of stability in my soldering, and that is not good at all here. Okay, you be gone. And you can go back here. You be gone. I am not needing a power lead. Now, for the people who are just in, by the way, this is me trying to solder one of those tiny ARM chips that featured on Hackaday recently, the HC32L110. I'm gonna try to get it to Blinky using purely debug soldering. I already actually cheated a bit because I do have a PCB with one already working on there, so I don't have to go through the software procedure. That's already proven working. I just want to see if I can debug this chip for shits and giggles. Okay. And this one needs to go here. Oh, yeah. That is, put it back maybe. Yeah, I'm going to call that perfect. I am happy with that. On to the next one. That's not. That is a super ugly wire end. What the hell did I do to that poor wire end? We're going to recut that. Ah, jeez. This really is that new wire cutter I just grabbed. No, it's not. It's the one with the big ass gap in it. Obviously, it's not going to give me anything useful. And it's so obvious. I mean, the good one is the blue one, and the bad one is the blue one. So, okay, I'm going to put that here. We can go there. That, what? Don't do that. Great. Those solder joints look super ugly, but they'll hold. They'll hold perfectly fine, I'm sure. I hope. Take this one, put it here. Let's Just gonna solder down perfectly fine. Happy little clouds. That is a solid connection. I'm not sure how I can call anything that's debugged to this chip a solid connection, but for all intents and purposes, this is a solid connection. Okay, so now I have ground, now I have power. You know what, I'm also going to solder one LED on there, because otherwise you just see me connecting and shout, hey, it works, or shit, it doesn't work, and that's not super interesting. Give me a sec, I'll look up an LED. LED. This is a random LED, so what color it is going to be a surprise to both you and me. And the resistor. Okay. Oh, no, wait, I'm still forgetting something. The thing has a reset input, and that needs to be connected to something. Reset. Yeah, let's do that first before I bugger off with fun stuff like LEDs. Yeah, whatever. You go live there. So I believe that they advise an RC network in order to deliver the power on reset pulse. I think you can also get away with just a resistor, but I'm not gonna. I have some experience with ESP32s where not having the RC network is you really want to have that on there. So I'm just gonna maximize my chances of this working by also putting an RC network on here. So the R is here somewhere, and the C is here somewhere. Come on, get there. And I need to cut off my wire. And I need to figure out which pin is the reset pin. Which pin is the reset pin? That is P00. That's also one of the middle pins. Oh boy, that's gonna be fun. Because there's one GPIO in the middle. If I ever want to get to that GPIO, I probably need to solder it now before I can't access it anymore. Okay, more pins to solder. Geez. So just for your reference, the reset pin is this little pad here, which means that it gets very hard for me to solder the one adjacent to it, which is just your old random GPIO. So I'm just going to solder that GPIO to somewhere right now, just so I can access it if I need it in the future. Let's put you down. Oh, wait, if I might just as well just solder that LED to that pin. I mean, I was going to do that anyway. A P01, and that is a general. Yeah, there's nothing particular wrong with that pin. You can connect a crystal to it, but you don't have to. Okay, an LED. I'm gonna connect that there. Yeah, that should work. Okay. Here's the plan. The LED is gonna live right next to the ground. Okay, LED, how are you? You've got a little arrow, which means that the ground is the non-green bit. Which means I can solder you here, and I hope that I can do it without desoldering the thing on the chip side. Ah, geez, that's not gonna. I'm gonna need a little bit more flux here. The issue is I really can't heat that joint, that ground joint too much, because if I do, oh geez, that thing wobbled again. I am so not happy with the wobble in that top pin. Right. What was I saying? Oh yeah. So the thing is, if I heat this up enough, then this big ass cable will wick the heat to that little pin there, and it'll desolder itself, which is not my idea of fun. So we're just gonna try very gingerly. Yeah. Yeah. That's straight, right? We're gonna call that straight. Okay, then we need a resistor. It could actually be that the GPIOs are currently limited to such a degree that you can actually connect an LED without a resistor. I don't know. I don't want to bother looking it up in the datasheet. And obviously, I just here's my resistor. Was about to say, just took a resistor, put my reel of resistors away, and now I can't find it. But it's not that bad yet. Easy, this one. Go do that thing. I'm gonna have slightly higher standards for you. Slightly. Okay. We're gonna call that an LED, and that needs to go to that pin. Geez. You can say what you want, but this certainly is exciting work. Right. But ideally, I also want to be able to connect to that, so maybe I should move that to a pin somewhere first. I guess I should, right? Oh, man. I could theoretically also decide that I don't want to bother putting more than one LED on there and just ignore all the balls that I'm not going to use, but that feels not right. Yeah, I think that's doable. Okay, let's solder this in place. Use a little bit more slack. Yeah, this is fine. Yeah. Sucky solder joint, we're going to call it good enough. Now, turning the thing around, sorry for dizziness. Where did I want to move that? Why is it way too long now? Well, it doesn't matter. Too long is something that can be fixed. Yes, you are. Okay, now how am I gonna solder this? I'm right-handed. If I were left-handed, this would probably be a lot easier. Oh no, that's okay. I can work with that. I can live with that. Okay, now we're gonna do the LED. I do want to have some more space here because I gotta go over and in. Come on. That's maybe too much. Right. Yeah, solder joints are super shitty, and this is even leaded solder, so I really shouldn't have any excuses. Well, aside from the fact that they're also tiny, and I'd rather have something that's working than a good solder joint that doesn't work. Well, then a beautiful solder joint that doesn't work. Obviously, a solder joint that doesn't work can't be called good. Is this way too long? Yeah, this is way too long. Mm-hmm. See if we can hold it at an angle. I can hardly hold it at an angle. Oh my. So that thing is there, and that needs to go to the middle. A stereo microscope is so useful now, otherwise I would have no idea where I'm pointing my tweezers. Okay, that should be enough. My tweezers are too big. Come on, yes. Cool. And my soldering iron turned off again. That's better. I mean, the good thing about the Metcal and I guess every modern soldering iron is that it doesn't take long to turn back on. The weller I started with, you could grab a cup of coffee before that was hot enough to solder with. I want to point you like here-ish. Okay. It's at least the right neighborhood. That looks like it actually made contact. Let's just poke the thing ever so slightly. Nope. Did make contact, but not enough. Probably only the flux that dried up. Okay, let's try the two-handed approach. Oh no, I think that actually went somewhere. Yeah. I poke that and it deflects instead of moving. Good, that's also a working connection. Now why did I do this again? Oh, I wanted to connect to the reset pin, and the reset pin was... Where was the reset pin again? The reset pin was P00, and that is on the other side of the V cap. In other words, we've got V cap going there, and that's going to be the thing right next to it. How am I going to route that? So the issue is I do need an RC network as well. So maybe I should solder that RC network in first. Just have at it. Oh, don't. I just almost whacked all my wires with my solder, which is not good. Okay, so this thing is upside down. Ah. Jeez. This is just 0603. I shouldn't have problems with this. Okay. Good enough. Where's my C at? My C ran all the way here. This is my C. Yeah, good enough. That was one of my boxes deciding to drop down on the ground. Oh, yeah. It's the drawer that my reels of SMD stuff are in. It's a shitty plastic thing, and I left the drawer open, seemingly too open. So now it dropped on the ground. It's not that bad because it's only reels that have fallen out. The drawers under them have all sorts of loose parts, etc. That would be a hell to pick up. I'll quickly clean it up and then I'll give you the lowdown again. Oh, I can also make it sound way more dramatic because they were reels of SMD parts. So what you just heard was about 20,000 components falling to the ground. Anyway, for all the new people dazed and confused, the little chip in the middle here is the little Hackaday. Yeah, exactly. The Olaf gave the type number. It's a little Wcsp 16, I believe, package, like 1.5 by 1.5 millimeter, and we're gonna try to solder it. So I actually already have a PCB with the chip on it, like properly soldered. So I already have software that blinks an LED, and just for shits and giggles and just to try if I can, I'm gonna debug it. So where we are right now is we have the power connected, we have SWD connected, we have one LED connected. All I need to hook up is the reset pin to a small RC filter for power on reset, and then we should good to go and see if we can make an LED blink. Okay, so where was I before everything? Here. So this is going to be the RC filter. You can see the R and the C. Now we need to hook that up all the way. That needs to scroll all the way around here and then to there. Yes, I'm gonna strengthen that somewhere halfway. Let's just scroll you through there. And then, oh jeez. Come on. You can do it. I mean, although technically this means that it's already stuck, right? That's not what I intended. Let's try and clean it up without making more of a mess, preferably. Oh, jeez. Oh, jeez. Jeez. Right. More flux. Yeah, good enough. And if not, more flux. There we go. Oh, geez, I mangled that bad, didn't I? Don't touch the... Yeah. Well, I'm going to fix it in place there as well, so I'm just going to say that it's fine. That mangled pad will hold, no problems. And I'm sure those words won't be quoted against me like 5 minutes in the future. Let's cut you off, just so we have something to work with. And we are going here and here. Yeah, it's fine. We'll call that straight enough. We'll just blob solder over it and no one will know. Jeez. I should actually have a webcam on me as well, just so you can see that I have my tongue at the right angle. Just call it art. Well, it's unique for sure. Let's put it like that. I don't think anyone else is going to be stupid. I mean, driven enough to do this. Mm-hmm. A little bit of solder there. Happy little wires. So this buggers off all the way. I really want that to be straighter. Nah, screw it. It's fine. Oh man, I messed up here. Honestly, that pad is now a slaughter. Hey, yeah, don't do that. You know what? I'm going to be brave and foolish and try to rescue this by also soldering the other half. Which probably means that in like 5 minutes you'll hear me cursing because I soldered to the wire that goes above there. Oh my. More flux? I guess I should have planned that out better. Yeah, I'm going to call it good. I actually should also, because now obviously, so the reset thing is here, but if I'm going to solder it like I'm doing right now, I won't be able to access that pin anymore. And obviously I can't have a pad that is useful for a perfectly good LED not being connected, right? That would be a shame at the very least. So I think I'm also just going to go out of my way and solder that. Hey, it's a bit loony. Hello. Okay. Yeah, I can probably wire that to there and then regret my life if that wire turns out to be super in the way, but we'll see. That is one of the, if you've looked at Hackaday recently, they had this tiny Wcsp ARM chip. Olaf, a little bit above, has quoted the type number HC32L110. So I actually have soldered that chip the proper way. I do have it on an actual PCB, and I already wrote code in order to connect OpenLCD to it and made it blink. But that is not fun, obviously. So I do need to debug it as well, just because, obviously. How's the stream going for all you guys, by the way? I'm actually doing this from Shanghai, from China, and you may know that YouTube and China is a bit, So this is being pulled through a VPN. I have absolutely no idea how well that works. I have no idea what my upload is. Ah, cool. That's good to know. Okay. Nice. Yeah, it's actually when I came to China, I went out of the way to write my very own VPN software from scratch, purely so I know that it won't match any existing VPN. So the likelihood of catching me on that is not very high. At least I hope they're not watching along. If so, ni hao. Solder that. I wanted to put this down there first. Maybe I should shape it first. Yeah, let's shape it first. Also, the thing that you probably can't see because it happens out of view, but every time, sometimes I move my tweezers or the wire or whatever out of the field of view, and every now and then it snags behind something, and it's probably fine, but I can't help but every time go like, oh crap, I'm pulling off one of those wires. It's more exciting than you would think soldering this. Yeah, focus. Come on. Ah, oh, that was just my tweezer. All right. So now let's move that down. Focus again. Like, yay. Yeah, good enough. No, I don't want to fully engulf that in solder. Hey. Okay, bye-bye wire. Get you at the right angle. Oh man. That is too far. That'll probably be okay. I hope. Yeah, it's wire wrapped wire, like the stuff with the isolation that you burn off. Now I kind of want to build on HUD so I can see the chat messages while I'm looking through the microscope. That is fixed. Okay, that's just a GPIO, so we can connect it to an LED later. But now the big scary pad in the middle. Yeah, maybe. How am I gonna? Oh, jeez. Let's shape it like this, and then like this. And I'm gonna turn it around again. Something like this. Now my gigantic cutters again. Let's cut it here. Okay. Come on. Yeah, there's solder on there. Okay, after this wire I can, oh geez, that coated the entire chip in flux. It's like an early Christmas, tiny early Christmas. Well, you know, I can use all the coating in flux that I can. An absolute worst case scenario, it looks shit, and then I take away the microscope and no one can see. Oh no, it melted. Oh, that went nicely. Okay, so recap. Yeah. This is the entire schematic. Again, sorry it's dark. I tried adjusting my microscope camera earlier, and that made the stream quit. So I'm not gonna try that again. So what we have here is the chip is here. There is the all-important LED here. This is a decoupling cap for the crap. That is a decoupling cap for the core voltage, and I should not have soldered my RC network to there. Okay, thank you all for helping me rubber duck debug this. Otherwise, and wondered what the hell's wrong. Right. Let me quit, and then I'll. So this capacitor should go to here, not here, because this is the 3.3 volts. This is not. Which is also going to be fun if later on we want to power it. Yeah. What's the practical bit about J-hooks? They're pretty useful if you want to desolder two sides. Now, if this thing can go over, then I can now solder you here. That needs to go there. I could bridge that, but I'm just gonna stick another wire in there. You go there. You go there. You go there. Right. You do not go there. Wow. That is actually the most pretty joint I made up till now. Okay. Okay, a little interlude there. Let's see if I zoom. This microscope is very hard to control if you're looking at the YouTube screen. Is this in focus? This is in focus. Well, it still looks like crap, but that's what you'll have to live with. Maybe I can... This helps a little bit. Okay. So again, to recap, this little thingamaboober here is the ARM chip. There is the all-important LED here with a resistor to a GPIO. This is a decoupling capacitor for the core voltage. The thing generates its own internal core voltage, but it needs a decoupling capacitor for it. This is the main 2.3 or whatever volt decoupling capacitor. And the thing that I just resoldered here and here is a little RC network that goes to the reset somewhere here. So those are the main components. There is a few other things here. These and these connections are for SWD, so I can program the thing. And with that, we should have enough to actually make the LED blink. So I'm just going to quickly grab my debugger. I am going to need another USB cable because I just used the one I had for my microphone. USB cables. USB cable. Wasn't that Alanis Morissette? 10,000 micro USB cables, and all you need is a mini USB cable? And of course, my soldering iron turned off again. Okay. Get you out of the way. Oh, this does improve the view by a lot. I should keep that in. The only issue is that this light is so reflective that if I look at the PCB without a microscope, I more or less get blinded, but you know. Okay. We need power. We need ground. Ground is here. And it's fine. One of these is SW. One of them is the clock and the other one is the data. I have no idea which is which, but it's only 2 pins, so I can flip them around easily. Okay. That is that. Then I'm now going to attach it to the SWD header and probably rip off everything because the programmer is so much more bigger than what I have here. Okay, I'll keep this in focus. So the only thing is that for my actual program, I used a different GPIO, so I need to swap those around real quick now. This is the 31. Okay, let's just initialize it as an extra 31. Cool. Okay, let's see if it connects. And it actually seems to connect. It is a Christmas miracle. And it actually programs as well. Let's see if it blinks. Is it blinking? It is not blinking. That is interesting. It actually is running. I'm uploading this via GDB, so I can just break it and see what it does. It actually is running, but it's not blinking for some reason. That is odd. Maybe I should. So there are multiple options here. Either I missed the pin. Oh, P31 is not the correct pin because I'm doing this entire thing flipped around and inverted. What pin am I looking at? Oh yeah, I remember this was the middle pin. So this is P01. It's right next to ground, so that is, yeah, P01. Okay, no biggie. Let's try that again. Flash the thing and run the thing. That looks like a blinking LED to me. Oh, people, you saw it first. The tiny little chip is certainly debuggable, programmable, and can do useful things in as far as blinking an LED is useful. Let's see. Have a little bit more time. I could just hook up more LEDs. Yeah, why not? Let's make a Night Rider or something. LEDs. That is an LED. And that is a resistor. So at least now I have video footage of it working. So if I mess it up, you guys have seen that it actually did work. And I'm not just saying it did. Second LED. Okay. You know what? Maybe it's not a good idea to start soldering on a thing that is actually working. I mean, technically, it's probably fine, but I'm gonna disconnect it. So the thing is that the last thing I want to do is replace the microcontroller because I blew it up. Ah. Well, that's a downside of SMD components. Here did my thing go? Yeah. Okay, retry. You go like this. That actually went better than I expected. I heated up that joint fairly long, but it didn't solder the wire on the BJ side. The issue you can have is that because the wires are relatively thick compared to their length, is that they conduct enough heat in order to desolder the wire on the other side, which means that I would have to redo that joint. And in the case of this joint, that's still doable, but there's a few other ones where I really don't want to do that. Happy little resistors. Yeah, I can just blob that together. That. Yeah, that sometimes happens. Happy little resistors. Okay, I can still connect 3 to there. Yeah, I might as well. It's dark here. I'm probably only gonna solder LEDs up to the point where it gets dinner time. Starting to get hungry, and my wife is cooking downstairs. Yeah, I know what you mean. I actually have really nice silicone wire here that has really thin strands of individual wires, which is absolutely great. Until like the wire accidentally is pushed down to some other wire or something, and then it's really not good. I like the fact that you can overlay wires and not worry about the isolation with this stuff. I actually have had to use that stuff because this stuff is relatively thin. I have no idea how thin it is exactly, but well, if you really want to find out, you can probably look at the components and measure it. But I have had a point where I needed to fix a nick in a flat cable, and this wire was like way too thick, and I did use it at that point. Yeah. Let's see. I wanna move all the LEDs that I just picked off the thing, so I'll never find them again. No, that just happened on accident. I probably want to connect the wires first and then worry about the LEDs. That is probably the right order of things. Or maybe I do want to do the LEDs first, because then I don't have to worry about desoldering the bit on the BGA. Choices. Well, I just said I didn't have to worry about that, so let's go with what I... Let's go with the wire first and then worry about the rest. Oh, that's already tinned. I can add a little bit more. Ta-da! Yeah, I do want to add a little bit more. So you can kind of see it under the microscope. This is like brand factory new, and it's already kind of, the edge is already bent away. Apenhaar, yeah. So the name for this that the Dutch industry uses, or at least a little bit of the people I know that I can call the Dutch industry, the term for it is monkey hair. Did just a blob of flux make its way over? Okay, I'm just gonna ignore that. Seemingly it's compatible with German as well. Great. Oh yeah. Yeah, let's zoom down first. That's probably a good idea. Yeah, you see that blob of flux there? That wasn't there before. Can you go away, please? Yeah, good enough. I don't want to desolder that entire joint. I do want to rotate it again. Man, best approach here. Honestly, that J-hook soldering iron point is indispensable here. It's not good for everything, for sure, but for small work like this is great. Okay, cool. What else do we have? I actually really want to solder that inner pad at some point, because if I don't do that at some point, I won't have the chance to ever do it again. What do you look like? Okay, yeah, that's good enough. How am I with regards to LEDs? I can take an LED and put it like that, and then I can probably take an LED and put it like that. Or maybe... No, I might... Okay, I'm just gonna solder this side pin here to... I'm gonna say this pad down here. So I can use this pad as the thing for the middle, and I can escape that way. Or maybe even this way for... No, because I gotta get that out of there. Yeah, we'll see. Okay, how much room do I need? I need yay much. That is absolutely great. The only issue being that if I'm going to solder this is going to be gigantically in the way. So let's move it a bit. Let's, yeah. Okay. PS RAM and NOR hooked up. Yeah. I'm probably gonna do this first. PS RAM and NOR kinda needs me to write lots of code as well. I can probably hook it up, but it doesn't work then. Also, I'm not sure what the use is because the PS RAM and NOR chips I have here are all huge compared to this thing. Oh, the Kvaljev? It's actually like the microscope helps so much. This is a pretty decent stereoscopic microscope, and you get so much better in soldering SMD if you use that, purely because the feedback that you get on the movement of your hands is so much larger than if you just peer through anything else. I mean, yeah, Doom textures. The issue is that this thing only has 4K of RAM, which is, I think, even if you include external PS RAM, I don't think it would be enough to do anything with. The only way you could get something working is to write a virtual machine or something that uses the external RAM, and I'm not sure if that at like this CPU works at 32 kilohertz. I think I'm not sure if that's enough for Doom. As in, I understand that you're saying this jokingly, but if there were any chance that this could be made to work, I would probably make it work. Oh, but if I want to take the center bit, I'm also not going to be able to connect to the next one. If I connect the next one there. But maybe I want to... Yeah, you know what? I'm going to hook up the other LEDs first. The other thing is it's getting near time for food here. So I don't want to leave you guys hanging if I'm off to eat something. Let's put you here. Stay. Yeah, it's straight. Ties nicely in the middle. It's connected on both sides. I see no reasons to fix this. C64 Doom clone. I could, in theory, I guess. That one there. No, I can just plug it up there. Yeah, let's go with that. Sorry, I'm gonna rotate the PCB a bit. That is the wrong way around. SMD diodes are a typical case of 50-50-80. Theoretically, the chance of you picking it up wrongly is 50%, which means that in 80% of the time you actually pick it up wrong. Yeah, let's connect the other LED as well. Yeah, it's actually such a shame. I thought about connecting this to a display, but the problem is that the only TFT that I have is like, oh, this is not visible. The only TFT I have is like yay big, so it's kind of, it doesn't really make much sense to connect a chip that tiny to it, because it doesn't really matter, right? You can also just connect a TQFN or whatever chip to it, and it would also fit on the back. Okay, where was I? Oh yeah, display, LCDs. No, not LCDs, LEDs. Another LED here. Ooh, that's a cold joint if I saw one. I don't have any particular project in mind for this MCU. It is simply the fact that it exists, the fact that it is tiny, the fact that this is a good excuse to try and solder a chip of this particular size. I mean, the nice thing is that they're pretty cheap. I think that those chips are like 50 cents each. So the idea was that if I mess up one, then it's no biggie. And obviously, that means that I haven't messed one up till now, because that only happens if chips are too expensive to properly mess up. But, you know. No, I'm better off moving that there, I guess. Yeah. Yeah, you could hide this in a cable. The issue would be that there's no USB stack on this particular chip, so you would need to have a software USB stack of some sorts. This is regular size perf board, yes. These are the components that you see are 0603. What are you? Yeah, I'm gonna say 0603, and this is all regular perf board. And it's kind of ironic that like the chip is actually the smallest thing on here. Okay, you gotta go to the negative. Come on, come on, come on. Okay. Technically, I could also solder an LED on here, but I don't want to bother because actually I want to pin out those balls first. However, it's also getting close to dinner time. So what I think I'll do is I'll just write a quick program to do some sort of Knight Rider-y thingamaboober. And then I'm going to call it a day. I'll probably finish up connecting the rest of the pads off stream. And I don't know, I also have OpenOCD support for this little chip. And I may just bundle it all up, make an article about it, send it to Hackaday. They'll probably enjoy to see someone doing a follow-up on the Hackaday thing. Okay, program. Which pins do we actually have? Let me plug it in again so you can actually see it and I can actually program it. Okay. Let's frame the thing on the lone LED. You are there, great. Oh, I actually just spotted I soldered an LED on there that doesn't go anywhere. Okay, so we're going to have 3 extra LEDs. Okay. And those go to the 3 bottom pins. So on the other side of the cap, that's 26, 35, and 36. This, 35, and this. Sorry, there's some off-screen coding going on, but stream this immediately to the webcam. So I can't show you my desktop. No, it's actually SWD, which is the JTAG 2-wire thingamaboober that's on most ARM chips. So it's actually nothing special. OpenOCD immediately detects it as just an ARM Cortex M0. The only thing is that the internal flash, in order to program that, I had to build a flash driver for OpenOCD, which is actually not that much work. I will open source that at the point where it doesn't look like absolute dog shit anymore. and I'll try to upstream it as well. I think the original manufacturer has plugins for like Keel and IEAR, but I don't have or want any of them. So this is programmed using just your old standard GCC for AVR on a Linux machine with OpenOCD. I'm just whipping up some real quick and dirty, like Larson scanner type code. Okay, I have absolutely no idea about the order of things. So I just programmed it. It's probably going to light up in some sort of order. We'll see. Okay. So one LED isn't working and the other two are green. Well, that's what you get when you get random LEDs from a random box. Now why is that LED not working? I probably just have the wrong pin, I guess. Oh, 353602. No, I'm looking wrong. That's the bad thing about that bugged chips. You always got to keep in mind that the pinout is inverted. This is 26. This is 02. 02. Okay. Continue. Oh yeah. We've got 3 LEDs that are all, 4 LEDs that are all out of order and all in a different color, but they do a Larson scanner type thing. So, probe. I'm kind of wondering if I could get a scope probe in on one of those BGA pins. Just for kits and giggles. Let me see how large it is. So if I were to probe it, would that work? So there's actually no scope connected to this because my Rigol takes an eternity to boot up, well, a minute, and it doesn't you can't see it anyway. I think I could probe those BGA pins. You just need to be very careful, and probing the middle ones would be a big pain in the ass. I can't really probe the red one here, but it should actually be possible. I mean, up till now, all my connections worked, which I'm really grateful for, but I could debug this thing. Okay, so I think dinner's almost ready, so I'm gonna call it a day. Let's see if I can shoot at least one beauty shot for if people want to have a thumbnail or something. Still messing down. and focus. Yeah, good enough. Zoom down a bit more. Yeah, you're welcome. All of you, thanks for watching. It's like 5 people more than I expected. I honestly just wanted to check if my hardware was good enough to stream, and if it would get around the firewall properly. I am happy to hear that it does. I might stream a bit more in the future. I have no idea if I'm ever gonna try something insane like this again, but who knows? So yeah, I'm really getting hungry, so I'm gonna cut it out. I'm gonna thank you all very much for watching. It's been a pleasure. I actually didn't expect this to go so flawlessly, and yeah, maybe until the next time, perhaps, possibly. So yeah, goodbye.